Welcome to the virtual Grand Canyon Star Party. Tonight we're going to look at about 10 to 12 objects for the next 90 minutes. It would have been nice, and we really wish we could have been doing this in person, but I'm glad that the technology allows us to do this virtually. We do have a picture of the telescope field up so that you can feel like you're there and ready to go. We're just not quite up at 7,000 feet. We are, however, streaming this under some very dark Arizona skies. So you're going to get a fairly realistic view of what we would have seen at the Grand Canyon. I encourage everyone to ask questions on the chat and interact with us as we go through this. I'm going to stop the share here for a minute and introduce our team. So I am Jim Knoll, and I'm from the Tucson Amateur Astronomy Association. And this would have been my 12th year at the Grand Canyon Star Party. Also with us tonight is Jim O'Connor. He's also a TAAA member. And a lot of you know Jim, and Jim's been the Grand Canyon Star Party coordinator for the past 11 years. And this is Jim's 18th year at the Grand Canyon. Operating the telescope tonight is Bernie Stinger. And Bernie is a dual member of TAAA and the Minnesota Astronomical Society. This is Bernie's second year at the Grand Canyon Star Party. So Bernie's now going to talk a little bit about the telescope.
Great. Thank you, Jim. What I'm going to be doing tonight is running the telescope and the go-to mount that it's connected to. Also, I'm going to be doing the image capturing through the software, and also the image improvement, if you will, or imaging software for tailoring the quality of the image. Now, I'll shift over to a picture of what the telescope looks like. And here you can see the telescope mounted about 50 feet outside of the building that I'm presently in. And this telescope is a Celestron C8 or 8-inch telescope. It's mounted on a Celestron AVX go-to mount. This is a motorized mount. And then up above, the optics, I have what's called a hyperstar lens, and the hyperstar lens allows for the images to be faster and also give me a wider field of view. In front of that is the astronomical camera. This is a video camera, astronomical grade video camera made by Mellencam. And this is the DS10C for deep sky 10 megapixel color camera, a video camera. And it has a thermoelectric cooler on it to keep the internal noise level down and improve the image quality. Now that blue cable you see coming out of it is the actual video line that's being fed back to me, so I can show you these live images that you're going to be seeing this evening.
Okay, thanks, Bernie. So let's go to our first object, and that is going to be in Gemini, the twins. And this is an object called M35, right in this area, right by the foot of the twins. It's an open cluster. So just as a refresher, for any of you that may not know, the Messier numbers were established or developed back in the late 1700s and early 1800s by a person, by an astronomer, French astronomer named Charles Messier. And he was actually a comet hunter. And he was looking for comets and kept coming across these fuzzy objects, and he wasn't quite sure what they were. He knew they weren't comets, and he didn't want to keep coming across them. So what he would do is he would catalog them so that he wouldn't mistake them as comets later on. Well, as it turns out, they're some of the best objects for amateurs to be able to view and watch and look at. And so with our better optics now, we have a great view of some of these. And there's 110 of them on catalog. So this is, like I said, this is M35. It's an open cluster about 3,000 light years away. It's about a +3 magnitude. Now magnitudes, the lower the number, the brighter it is. So usually if you're from a dark site, about a +6 magnitude is generally your naked eye limitation. So any number smaller than that is generally available with the naked eye under some decent skies, certainly with binoculars. So this is a +3 magnitude. And as I mentioned, it's near the foot of one of the twins. And so what happens is when stars are formed, they're formed out of a nebula or a cold hydrogen gas cloud. And after the cloud is used up, then they become an open cluster, and they'll travel around the Milky Way as an open cluster.
So here you should be seeing M35. M35 is this cluster of brighter stars just off to the right center. These are, as Jim said, this is an open cluster. So you can see they're spread out over quite a large area. And also in just above it, you'll notice another faint fuzzy object, which is another open cluster. And I'm going to pass it over to Jim O'Connor to tell you about these objects.
Thanks, Bernie. Open clusters are usually young objects. When they first form out of this cloud of gas, they pick up the rotation of that cloud. And so that rotation stays with them as they mature and become stars. And they start rotating away from each other. This cluster itself is rather unique in that it's fairly old. As open clusters go, but there are so many of the stars that their gravity is kind of overcoming rotational dynamics. The small cluster up at the top is about 4 times away from us, but it's almost 10 times older than M35. That cluster itself has so many stars and it goes together that it likely never will disperse across the sky.
All right, good. So that just, if you look at that, you can see now that, there's a nice little cluster there. So those stars, like Jim said, were fairly young stars grown out of a nebula. And they travel around the Milky Way together as a family unit until eventually gravity will lose out and the outer stars will start drifting away. And then the cluster will get smaller and smaller. So now we're going to jump out of our galaxy and we're going to go look at a system or a cluster of galaxies in the constellation Leo. So this is called the Leo triplet. And if you can see where my cursor is blinking right there, it's right at the hindquarters of Leo the lion. When you look up in the night sky, and Leo is kind of off to the west right now, but a lot of times you can see what looks like a backwards question mark. So there's a star called Regulus right here that my cursor's on. And if you look up, you'll kind of see a question mark that's backwards. And that's the mane of the lion. And then the rest of the lion is back behind him, his hindquarters. And so this is Leo the lion. So what we're looking at now is we are looking at a triplet of trio of stars. Let me zoom in a little bit. You can see right there that there are 3 clusters of galaxies, not stars, galaxies. 2 of them, M65 and M66, are kind of face-on galaxies. We're looking at the top down at the galaxy. from above, basically. And then this little guy right over here is a galaxy called NGC 3628. And we're looking at the edge of it, just like you were looking down kind of a CD. So you're seeing all that light from the galaxy concentrated in a sliver of light. And so we're kind of looking at the edge. And so these are called the Leo triplet. They're about 35 to 40 million light years away. So when Bernie shows us what's on the scope, the light you're seeing actually left that galaxy 2/3 of the way back towards when the dinosaurs were roaming Earth. So we're actually looking back in time at what the galaxies looked like then. Now, 35 million years is really just a drop in the cosmic bucket. It's a long time for us, but it's a short time for galaxies and stars. They're about magnitude 9, so they're not naked eye visibility. And they are just slightly smaller than the Milky Way. The two big ones here are just slightly smaller than the Milky Way. They're about 70 to 80,000 light years across. And so our galaxy, Milky Way, is about 100,000 light years across. Let's see. And they were the smaller one. Actually, Messier didn't see this one. He just saw these two when he cataloged them. This one was discovered by an astronomer by the name of William Herschel back in 1784. There is a tidal tail that goes between these galaxies. So these three galaxies are actually interacting with each other. And there's about a 300,000 light year tidal tail between the two. So Bernie, if you're close to getting the scope set up, see if you can grab the screen from me.
So we should be seeing now the what's called the Leo triplet. The three galaxies are obviously very apparent. This is M65, M66, and NGC 3628. These were discovered by Charles Messier in 1780. And M65 is a standard spiral. M66 is a slightly barred spiral. So if we zoom in on them a little bit, you can see so this would be 65 being a standard spiral, 66 being a barred spiral. You can see it has kind of a bar appearance in the center core, giving it that barred spiral name. There's been a number of supernovas in M66 since 2018. However, most of them are extremely dim and they haven't been observable in most telescopes. This was actually discovered, this NGC 3628 was discovered by William Herschel in 1784. Quite a few years later than Charles Messier discovering these two, because this one's quite a bit dimmer and probably was beyond the range or the capability of Messier with his small telescope. Jim O'Connor, did you have something to say here as well?
Yeah, I'd like to first point out that the image you see looks upside down from the planetarium program, and that's because Bernie's camera is at the secondary mirror of his telescope, and it flips the image. It's got one image flip in there, so that's upside down from what the planetarium shows, but it's a lot better looking. The second thing I'd like to say is that while we're talking light years, just that 1 light year equals 6 trillion miles. And that if you're out hunting for Leo sometime and you don't have a star map, the easy way to find it if the Big Dipper is up is to punch a hole in the bottom of the Big Dipper, and the water pouring out of it is going to rain on Leo's head. So if you can find the Big Dipper, look at the bottom of the soup ladle that's up there and follow it in a straight line, you'll get to Leo.
Okay, excellent. All right, I'm going to grab the screen, and now we're going to move over just a little bit and take a look at the star that I mentioned earlier in the bottom of the question mark, and that is called Regulus. So Regulus is Alpha Leonis, so that's the brightest star in the constellation of Leo. Stars generally will do the Greek lettering for the brightness of the stars. So it is the bottom of the question mark. It's about a magnitude 1.35, so it's fairly bright. It's actually the 21st brightest star in the night sky, and it's 77.5 light years away. So when we look at the telescope, we're actually going to be looking at what the star looked like a little over 77 years ago. It is right on the ecliptic, which is what we call the apparent path of the sun and the moon. So it's where the planets and the sun and the moon basically traverse the night sky, sun during the day and everybody else at night. And so it's right on the ecliptic. It's also known as the lion's heart. It's about 12,000 degrees Kelvin. So it's about twice as hot as our sun is. Our sun is about 6,000 or 5,600. And it's about 3.5 times larger than the sun. But it is fairly young. Our sun is 4.5 billion years old. This star is about 1 billion years old. And it's actually a 4-star system. So we should be able, when Bernie gets the scope on it, hopefully we'll be able to break out those stars. The main star for Regulus has a small little dwarf associated with it. And then the other two are a pair that are about 100 astronomical units away from the main star. So what that means is that an astronomical unit is the distance from the sun to the Earth. Bernie, are you able to grab this share now?
So you should see Regulus here, obviously the very brightest star on the screen. And this is its companion over here on the side. Although this is a binary system, it really doesn't split. There's just not enough separation there to get those two stars apart. But this is the beta star, I believe. Interestingly enough, the planetarium program that I have, and that you may have as well, Jim, shows a galaxy right here. It indicates a galaxy right here, and it actually even gives it a name. So it was a named galaxy. And I've seen it in a couple of different planetarium programs, but it's not there. And reading in some of the astronomical publications, no one knows where it went. So it's the case of the vanishing galaxy. And obviously, galaxies can't vanish. They're not a thing. They're composed of many, many, many stars. So it's very impossible for that to vanish, at least not under any functionality that we're aware of. Most assume that they think it was perhaps a ghost image of the really bright star just showing up as a smear in people's optics back when it was named and numbered. So that's the vanishing galaxy.
So the bright one is the main star. We can't see the small little dwarf. And then the other pair are the ones just to the left that you can't break out the pair.
Right. You can't split the pair. They're too close together.
Jim, you want to add anything in on Regulus?
Yeah, Regulus may seem unusual in its name. It was decided in 1929 that the stars, for scientific compatibility of the research work that was going on, the stars would have their Arabic names. This one is called Regulus, and that's in honor of Copernicus, who was a combination astronomer, astrologer in the middle of the 16th century. He was, as most astronomers, as all astronomers were back then, really an astrologer. And he thought all the stars had character. And he was looking for which star was the boss. And so what he did was he came up with the idea that the star, with its Arabic name, which no one uses anymore, was really the king of all the stars. And he first called it Sidereus Rex. And it just sounded too clunky. So he changed it from his Polish language into Latin, and it became Regulus, which he thought meant the regulator, but really it means the little king. So that's one of the few stars in the sky that does not have its Arabic name.
All right, nice.
By the way, these are designated Regulus A, or this is Regulus B and C being a pair, and then the little dwarf off to the side, which we can't see. Obviously, it's too small, is Regulus C. I'm sorry, D. A, B, C, D.
All right. Very good. All right, so that is the star Regulus in the constellation of Leo. So let's come back to the planetarium program. Now we're going to move a little bit below Leo and below Virgo, and we're going to go take a look at a galaxy in the constellation Virgo. It's called the Sombrero Galaxy. The Sombrero, once you see what it looks like in the telescope, you'll kind of get an idea. So remember when we were looking at the 3 Leo galaxies, we were looking at 2 of them from the top looking down, and that's kind of what we call a face view. And then we had the third one, which is an edge view, where all the light's concentrated on the edge. And that's what we would be looking at when we're looking at M104. Make sure that for some reason the sharing stopped. So it's called the Sombrero Galaxy. So when we look at it, there's a dark dust lane going right through the center. And so it almost looks like the brim of a hat with the bright core of the galaxy above and below it. So it makes it kind of easy, and it almost looks like a sombrero hat. It's about 30 million light years away. So it's kind of in our little cluster of galaxies in our supercluster. It is slightly larger than the Milky Way galaxy, but just slightly. It's about 110,000 light years across, where our Milky Way is about 100,000 light years. So actually, it's about 130,000 light years across. And it's a magnitude 8, so you can't see it visually. You need a telescope or some binoculars. And one of the ways you can kind of find it, it's really close to Corvus the Crow, but if we come up here to the Big Dipper, so this is Ursa Major, the Big Dipper, you're going to see kind of a bear up here. And the tail is the handle of the Big Dipper. And so as you kind of arc from the handle of the Big Dipper, you come down to a star called Arcturus. And then from there, you do what we call speed to Spica or spike to Spica down here in Virgo. And then you come right over here, and this is Corvus. It's a little polygon, 4-sided, out of equal sides, and that's the Crow. And then about 5 degrees above that star is where the Sombrero Galaxy is.
All right, so I've got it on the screen. It's a little bit small right now because it takes up a small field of my entire view. And I'll zoom in on it. You'll get a better idea of what it looks like. So there's the Sombrero Galaxy. The Sombrero Galaxy is one of my favorites. It's an all-time favorite for most Star Party attendees because of its beautiful dust lane that goes down through the center of it. The Sombrero Galaxy was discovered in 1781 by a French astronomer by the name of Pierre Messier. But it was added to the Messier list later on, and that's why we see it in the Messier list as well. Interestingly enough, M104 was added in to the Messier list in 1921. Messier made his list in the 1700s. So why so late? Well, the reason for it was that the original Messier list didn't have 110 objects on it. It had slightly over 100, and M104, or the Sombrero Galaxy, wasn't on the list, but researchers saw reference to it in Messier's notes, and for some reason he just didn't put it on his list. So it was posthumously added to the list back in the early 1900s.
All right. So now what we're going to do is we're going to stay on Bernie's screen, and he's going to show you how and talk a little bit about moving the telescope to the next object.
Right. So the next object that we want to go through, we've got a satellite going through. Satellites are becoming more and more of a nuisance for astronomers in general, but not much we can do about them, so we have to deal with them. I'm going to be moving over to M61. So let me put in M61 to my system, and I'm going to tell the telescope now to slew over to M61. So you will see here now a smearing of stars as the telescope moves over to M61. So all those streaks you're seeing in the screen there are actually stars going by. The camera is continuing to operate during the time that it's moving, so the stars that are going by in its field just end up being streaks. So now we've reached M61, and I'm going to zoom in on it a little bit, make it a little brighter or a little larger. And there's M61. Now I'm going to drag onto the screen so you can kind of get an idea. This is the processing software that I'm using to improve on the image quality. For those of you who are technical, I'm changing the black level and bringing up the black level in the histogram so that the background will look a little darker. I already have the exposure at 5 seconds. I'll probably leave it at that point. And I'm going to do a live stacking. Average stacking reduces the noise in the image. So a lot of this kind of fuzziness that you see in the background area here will start to disappear as that live stacking kicks in. So I'll move that back out of the screen here. Just wanted to give you an idea of how that worked. And here's M61. Now M61 is a nice little barred spiral, but that is not the reason why we've gone to it tonight. The reason that we've gone to it tonight is because M61 has something special going on. You'll notice these stars, these white objects or white lumps in the screen surrounding the galaxy, these are foreground stars in our galaxy. These stars are tens or maybe 20,000 light years away at most within the Milky Way. To see this distant galaxy, we have to look through our galaxy and the stars in our galaxy. So we're seeing those stars. These stars here, this one, this one, this one, this one, those are stars in our galaxy. But this, what looks like a star right here, is not a star in our galaxy. That is a star in M61 itself. Now, why can we see a star in M61 when it's so far away? Well, the reason for that is because that is a supernova. That star went supernova. That star in this arm of M61 went supernova on the 6th of May. So it is a relatively newly discovered supernova. And right now it's bright enough that we can see it with the use of a good telescope. In fact, if you have your own telescope and you can find M61, you can try to spot that supernova for yourself. That supernova is called SN 2020 JFO, and it is a type 2 supernova, which means that it's a sun that was in the range of 9 to 40 solar masses. In other words, between 9 and 40 times the size of our sun, and it reached the end of its life, and when it did, it exploded into this massive explosion. And this will stay visible for probably a couple of months before it starts slowly fading away and eventually becoming invisible again.
So that galaxy is 51 million light years away. So that star went supernova 51 million plus about 15 days ago.
That's right.
So we like to say in astronomy, we're time travelers because we're looking back in time at when these things happen. And so that's kind of interesting. And you know, I'm sure there's probably another civilization there that maybe is looking at our Milky Way and some of our supernovas, thinking the same thing. Let me grab the screen and I'll show you where it's at. So we moved from down here, we moved right up into the center of Virgo. And so the galaxy is right there in Virgo. All right. So now we're going to shift just a little bit and we're going to look at the Virgo clusters. So while Bernie's moving the telescope, I will take a look at M84 we'll start with. You didn't have to move very far, just going up a little bit. This is called Macarian's chain. And if you look in here, and Bernie, hopefully you can just grab the screen from me when you get there and give it a try. If it doesn't work, just let me know and I'll stop. But this is called Macarian's chain in the Virgo constellation. So it is our local supercluster, kind of the center. This is M84. This is M86. This is what's called the Eyes galaxies, which you can just see this chain of galaxies coming up here. And then this is a monster over here. This is M87. It's a huge elliptical galaxy. So this supercluster, we belong to the supercluster. So these galaxies are 50 to 60 million light years away from us, but they are part of our supercluster of galaxies. There's probably about 100 galaxy groups, and so we are just one group of that. And so around our Milky Way galaxy. So our little local group we've got right here, we have the Milky Way, and then we have the Andromeda galaxy, which is about 2.5 million light years away. And then close to the Andromeda galaxy is a small galaxy called the Triangulum galaxy. And we all have some satellite galaxies around us. There's about 50, I think 54 or so galaxies in our little local group. If you've ever been to the southern hemisphere and you've seen the large or small Magellanic Clouds, those are small satellite galaxies of the Milky Way. So we have our little local group, and we're kind of coming together slowly. In probably 4 to 5 billion years, Milky Way and Andromeda will merge. So we're gathering together, and then, like I said, the very center of this big cluster is called the Virgo supercluster. And M87 is kind of the middle of it. That's kind of the heavyweight in that area. So M84, this guy right down here, is about 60 million light years away. M86 is 52 million light years away. They're about magnitude 9 to 10. They're both elliptical galaxies. And the M84 is about 100,000 light years across. So it's about the same as our Milky Way. M86 is about twice the size of our Milky Way. It's about 190,000 light years across. And the eyes are pretty small as well. They're about 52 million light years away and about 100,000 light years apart. Bernie, you ready? Can you grab the screen?
Okay, there's the Macarian's chain, just as Jim was showing you a minute ago. As you can see here, the chain really starts here and works its way around this way. So here's M84, and here's M86. Here's what Jim was referring to as the eyes. And there's another pair, and another galaxy, and another galaxy. So this makes an interesting chain of galaxies in the constellation Virgo. And off to the side here is M87. Now, also, what you may or may not have shown, Jim, and I apologize if I'm redundant here, but off to the either side of M86, M84 are several other galaxies as well. In fact, if you look closely, everywhere you look are galaxies. So these are the big galaxies, M86, M84. And if we come down here and take a look at the eyes, they make an interesting pair because of the way they look a little like little slits, like one eye and another eye, and almost like a mask of sorts. Here's one eye, here's the other eye, here's kind of the nose and the forehead, and there's all a number of different ways of looking at this, but an interesting combination nonetheless. And then down below it are two more galaxies, and the galaxies just keep going on and on. Here's another one down below. In fact, if you look closely, there's probably 20 or 30 galaxies here in this area. Everywhere you look, these look like little smudges. Here's another one over here. There's another one here. Here's another one, another one, another one, another one. Everywhere you look are galaxies. So this is a good indicator of a visual indicator of how large the Virgo supercluster is and how many galaxies are involved with that supercluster. Another thing I'd like to point out is on M87. M87, of course, has the supermassive black hole. And on a good night, you can see the jet from that supermassive black hole. Now, I'm I'm not seeing it there unless somebody else can make it out. I'm not seeing the jet this evening. But on a good night, there'll be a little kind of dagger on one side, which is the jet from that supermassive black hole. But I don't see it there this evening.
No, I don't see it either, Bernie.
Some nights are better than others.
Yeah. If you're going back to M87, if you guys remember a couple years ago, they took an image of the supermassive black hole in the center. And that was done by a system of telescopes called the Event Horizon Telescope. What that is that's 9 and expanding up to 11 telescopes across the Earth, and they're all linked together to basically give you the aperture of the Earth. And they used these telescopes to take an image of the material going around the black hole. And there's so much data involved that you just don't link these telescopes together. They download the data on hard drives, and then they FedEx them or ship them to a central place. I think here in the U.S. They put all the data together, they crunch the numbers. It takes a while to do that, and that's how they took that picture. They have 9 telescopes right now. I think next year they're supposed to go up to 11, so they'll be able to get even better objects. All right, so that's kind of the Virgo supercluster. Pretty cool area. Let me grab the screen from Bernie. And so, again, that's where we were looking. And so now what we're going to do is we're going to go over to another cluster. And this is called the Coma cluster. And this is in Coma Berenices, which is the hair right here. It's Coma's hair, I guess, or Coma means hair, Berenices hair. But it's just down below the hunting dogs, which, if you look up in the night sky, all you see is these 2 stars. So I don't know how you get hunting dogs out of that. I guess you do. And anyway, that's the Coma cluster. And zooming in a little bit, you'll see, and we'll show it on Bernie's telescope here when he gets it over there, but you'll see another really nice cluster of stars. And it's what we're looking at right in the middle of these guys, these 2 guys right here are supergiant elliptical galaxies. They're about a magnitude 11, so they're really tough to see with your naked eye. But this cluster in here shows about 100 or about 1,000 galaxies, and they're approximately they're 300 million light years away. So if you think about it, the light we see, and Bernie, let me know when you're ready for the screen, and I'll send it over to you. The image that we'll see in Bernie's telescope, that light left those galaxies basically when, if you think about the Grand Canyon, you go back to the Grand Canyon, it's when the Kaibab limestone, the very top layer of the Grand Canyon, was formed when that light was leaving those galaxies. So even though the Grand Canyon is a look back in time, as is astronomy, based on the different layers that you're looking at. The cluster is about 20 million light years across. There's lots of galaxies there, and if you think about the difference between, like in the Grand Canyon, if you go down to the bottom of the Grand Canyon, you're looking back in time about probably almost 2 billion years is when that was formed, and so that area right there in the solar system is only 4.5 billion years old. So the bottom of the Grand Canyon is about as old, about half the age of what the solar system is. And then the universe itself is only 13.8 billion years ago old. So it's still relatively young compared to that. Both these galaxies are huge. They're about 330,000 light years across. The larger one and the smaller one's about 260,000 light years. You ready for the share, Bernie?
Just getting there, Jim. This galaxy group is quite a bit fainter, so I have to do a longer exposure
Okay, no problem.
to reach down to it. I can grab it from you, and
Okay.
we can get an idea of, maybe I'm processing it while they're watching.
Yeah, and while Bernie's bringing that up and processing it, let me just tell you a little bit about Stellarium. The planetarium program that I was using is actually a free program. So if you go to stellarium.org, I think it is, you can download it, and it will allow you to kind of move around the night sky. You can set your location and the time, and you can zoom in and out, and you'll be able to find different kinds of objects. So it's similar to some of the apps you can get on your phone. But this is going to be on the computer. So it's a great little program. You can set the different artwork and the line drawings to be different cultures. Like if you wanted to look at what the Navajo sees in the night sky, you can show that. You can see the Western culture as well. So now if you look kind of right in the center, you're seeing the two big galaxies. And it looks like a satellite going through.
Yeah, we just got bisected by a satellite. Okay, it's coming through now a little bit. So what you're seeing there are the two brighter galaxies of the Coma cluster. And those two brighter galaxies are they are in the 300 million light year range. So we're looking about 3 times further away at the Coma cluster than we were at the Virgo cluster, which we just looked at previously. So these are not only fainter, they appear smaller because of the distance away they are. As you can see, these are the biggest galaxies of the group. There's also another one here. And some of these, what look like stars, are actually galaxies as well. Here's another one. Here's another one. Here's another one. Looks like another one here. So there's, from my vantage point, I can see maybe 20 or 30 objects, galaxy objects there within this field of view, the Coma cluster of galaxies. According to documentation, there's over 1,000 galaxies in this group, but I'm not sure that I can reach all 1,000 of them. Maybe a handful because of its distance.
All right. Yeah, so we're kind of on a little bit of a galaxy hunt tonight, which is good because Bernie's setup is really good for doing galaxies and has a nice wide field of view. Okay, so now we've kind of moved a little bit to the south, and this one's a tough one for anybody that's very far north in North America. We're looking down in the constellation of Centaurus. If you're looking at the planetarium program, you can kind of see the horizon going through here right now. This object is only about 8 degrees above the horizon, so it's pretty low. And this is an edge-on galaxy. It's a spiral galaxy, about 13 million light years away. So it's only probably about 6 times further away than the Andromeda galaxy. So it's relatively close and fairly low south. So Bernie, you can show them on the telescope.
Sounds like a plan. So you'll see on your screen a galaxy, as Jim pointed out, this one is quite low on the horizon and a difficult object for anybody in up in the northern or even central areas of the U.S. It has an interesting kind of reddish glow to it. I find that unusual for galaxies. And this particular one doesn't have an M number, a Messier number, even though it's magnitude 9, which is a fairly bright galaxy in its own right. So why is that? Well, it's because Charles Messier was in France, and at that high latitude, they couldn't see down this far south, or if they couldn't see very well that far south. So they never cataloged these objects. Fortunately, down where we are, we can still reach it. This was actually discovered in 1826 by Charles Dunlop. He was an Englishman who no doubt sailed down to probably Australia, would be my guess, and started doing sky charts of deep sky objects from the southern hemisphere. It's about 11 million light years distance, but it's not part of our local group. It's not part of the Coma cluster. It's not part of the Virgo cluster. It's actually part of the Centaurus galaxy group.
All right. Yeah. So that one's kind of a tough one to see from northern latitudes, but it's a really cool one when you're far south. All right. So we're not going to move very far at all. We're going to move up just a little bit, and we're going to look at one of my favorite objects, and it's usually only visible for a couple of months in the May-June time frame. And this is an object called Omega Centauri. So it's down in Centaurus as well. It's it's called a globular cluster, which are some of the very old stars in our galaxy and basically in the universe. This one's about a magnitude 4, so it's bright enough to be seen naked eye if you've got some decent skies. It's one of the brighter globulars in the night sky. So we kind of call this is where the older stars go to live out their senior days. If you think about a galaxy, in the center of the galaxy where all the core is and where all the bright stars are having a good time, well, that's where all the partying is taking place. That's where all the fun activity is. And then as they age out, they kind of separate above and below the plane of the Milky Way galaxy, of the galaxy. And that's where the globulars tend to hang out. And they usually are in towards the core, but they're above or below the plane of the galaxy. And some of them can be quite huge. This is the largest globular cluster in our Milky Way galaxy. It's about 16,000 light years away, and only about 200 light years across. And there's probably a million stars or several million stars in this little 200 light year span of cluster. And so if you were on a planet around one of these stars, I mean, you would have a sky full of stars. They'd probably, the nearest star to our solar system is the Alpha Centauri system and Proxima Centauri, which is 4.2 light years away. Well, this one's got several million stars in the span of just 200 light years. You can go ahead and show the telescope, Bernie, anytime. They think that they've detected a black hole in the center of this cluster. So chances are this might be the remnants of a small galaxy that the Milky Way consumed back in the early days.
Yeah, Omega Centauri was discovered by Edmund Halley in 1677. Edmund Halley, for those of you that might ring a bell, he is the discoverer of Halley's Comet. Halley also did a number of other discoveries, including Omega Centauri. And like Charles Dunlop, who I mentioned earlier, probably went down to the southern hemisphere to look for objects in the southern sky that had not been seen before. The 1677 was actually 100 years before Charles Messier. So this was cited long before Messier was even born and created his Messier list. And yet it never was on the Messier list. And again, because it's just too far south. And Messier probably never saw it and never added it to his list. Notice on the image here, there are a number of different colored stars in the field. Many of the stars within the globular are older, reddish orange, older stars. But if you look in the upper corner here, you'll notice there's a couple stars here. One's kind of reddish and one's blue, and they're right next to each other. So there's quite a few different ages of stars that populate this area.
All right, Jim, you want to talk anything about globs?
Yeah, they're so old. They're some of them go back to over 13 billion years old, which is getting very close to the beginning of star formation in the universe. And when the stars back then were formed, and these globulars tend to be between 10 and 13 and a quarter or so billion years old. When these stars were first formed, a lot of them are very big. They don't have a very long life. What ends up happening is that they go to supernovas. So there are a lot of supernova remnants floating around inside a globular cluster. Usually, the majority of them form neutron stars that are floating around in there. So the stars we see today are the ones that are within the measurements we're getting into from 100,000, 150,000 light years or less. The stars we're seeing today are the medium-sized stars, like our sun, maybe up to 6 or 7 times as massive as our sun. And when they end their life, they end it more benignly, and the gases just sort of run away, and they leave behind a carbon-based white dwarf. Well, if you take a look at Omega Centaurus, what you end up seeing is less than a tenth of a light year separation on average between these stars. This is a very busy beehive. It's got neutron stars sitting in there. It's got some small black holes running around. And in the case of Omega Centaurus, an intermediate mass black hole at the core, which is the fingerprint of a galaxy core. That probably got its gas taken away at the time the Milky Way was forming because of the extra gravity. Well, because of that beehive of stuff moving around, sometimes they run into each other. And as Bernie was pointing out, a red star and a blue star, globular clusters have a thing called blue stragglers in them. And that's caused by some of these objects actually running into each other. White dwarfs might collide, a white dwarf and a neutron star might collide, a star and a neutron star, a star and a white dwarf, all kinds of different collisions can go on. Well, what happens then is subatomic it gets ripped into subatomic particles, hydrogen is formed all over again, and it forms new stars. So you'll get blue stars in there that have an age that's only a tenth or less than the overall average age of that cluster, or you'll have red giants of average size stars that are just getting to the end of their life. So this is, if you've got enough capability with a big enough telescope and a really super photographic system, you can actually see red giants floating around with blue stragglers. So that's quite a stellar retirement home, as was mentioned. And they about a third of them have been found to have, a third or less, been found to have intermediate mass black holes in the middle of them. The rest of the concept is that maybe they were formed out of big clouds of gas, and there's just too many of them to separate. But there's so many stars in such a small place, they hold their shape until a long time after we're gone.
All right, cool. So last one we're going to look at tonight is another galaxy not too far away. We're going to stay on Bernie's screen here, and he'll show you again about moving the telescope and tweaking the system.
Thanks, Jim. So I'm going to move the processing window back into the screen and start preparing it for the next object. Back it off to a shorter exposure time. And now I'm off screen. I'm going to plug in the name of the next object that we're going to, which is NGC 5128. 5128. And tell the program to slew the telescope over there. And you'll notice now we're in the process of shifting over to the next object.
So this is another very southerly object. But it's relatively close. It's a magnitude +7, but it's only about 12 million light years away. So this one's relatively close, and it's just slightly higher than Omega Centauri. It's about 4 degrees higher in the night sky. So it's still pretty low, but it's actually it's the 5th brightest galaxy in the night sky, so it's fairly bright. Got a very bright central bulge that Bernie can kind of point out now.
And although we didn't specify what its name is, it's known as Centaurus A. So I've increased the exposure time to make it stand out a little more clearly. And we'll touch up the white balance just a little bit. And then we'll remove the background. And we'll do a little average stacking on it. And that will clear it up immensely. So there is Centaurus A. And as Jim pointed out, this is one of the brightest stars in the galaxy, or within our field of view, at least from Earth, from our night sky. Not the brightest star in the galaxy, I'll take that back. It was discovered by James Dunlop. James Dunlop was the son of Charles Dunlop, and it was discovered in 1826 from Australia again. And it is a spiral galaxy, although it doesn't look like a spiral galaxy, with a huge dust lane across it. And this galaxy was one of the first galaxies to be verified as giving off radio waves. So not only does this galaxy give off light, it also is a radio emitter. And radio telescopes aimed at it can actually hear it. It's that active. And most of that radio noise is from the supermassive black hole at its center. Jim, do you have anything on that one?
Yeah, the dust lane looks like it was due to a collision with a small spiral and a large elliptical galaxy, and it formed massive, went into a massive starburst formation period that's still lasting. And the fact that it's forming lots of stars on the inside is pushing the debris out. And you see that as the hamburger and cheese in the hamburger galaxy out there that we're looking at. And it's still very energetic, enough so that, as Bernie was saying, there's a lot of radio energy and other frequency energy coming out of that object. It's very electromagnetically hot, and a lot of energy going on pushing that debris out.
All right. Well, thanks, Jim. That was a good wrap up. So this is our last object. We'll give you a little taste of what it was like up in the Grand Canyon. This is one of our pictures from last year. You can see some of the telescope field and a nice bright Milky Way and the sky showing up nicely. So I hope you guys enjoyed our little tour of the universe tonight. It is kind of nice that we were able to do this virtually instead of having to cancel it all together. And I'm going to stop the share here for a minute, and we'll kind of wrap things up. So assuming this virtual does work, which hopefully it will, for future star parties, next year we might actually try to do a virtual live feed while we're doing the in-person one, which would be really cool. We might be able to give a lot more people the interaction of being able to do the star party without actually being there. It's always much better in person, but if we can share this, I think amongst across the country and the planet, I think that's even better yet. Next year's Grand Canyon Star Party is scheduled for June 5th through the 12th, so fingers crossed that everything's going to be good. We will be ready to go. Bernie, Jim, any last thoughts?
Just wanted to thank everyone for coming tonight and watching our virtual party. I see it as state of the art and something that we hope to continue in the future. Thanks for coming.